another great use of the law of cosines is when we have a triangle where we have three sides that are giving a side, 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 or an SSS triangle. An SSSS, three S's, a side, side, side triangle. So in this particular one, I wrote an example where we have three sides that are known, but none of the angles. 4, 6, and 9 are the sides of the triangle. So first of all, let's just ask the obvious questions. Is the law of sines helpful right now? No, it's not, because any ratio of the law of sines would give us two unknowns. And we can't solve an equation with two unknowns. So let's look at the law of sines. Typically, when we know the three sides, the best place to start is let's find the angle opposite the largest side. So in that case, let's use this b squared equation that we have. Let's solve that for the cosine of b. That's the angle that we do not know. So I'm going to subtract these two from this side. So b squared minus a squared minus c squared equals minus 2ac cosine b. Divide both sides by minus 2ac. So I have b squared minus a squared minus c squared all over a negative 2ac equals the cosine of b. All right, let's crank out the work that we can do here. Just double checking, did I miss anything? All right, b, 9 squared, minus a squared, 6 squared, minus c, 4 squared, all over minus 2 times a times c equals the cosine of b. All right, let's see if we can do some work here and figure out what we got going on. 9 squared, 81, minus 36, minus 16. On the bottom, negative 48. 81 minus 36 minus 16. 36 plus 16 is 52. 81 minus 52 is 29. So that equals minus 29 48. So cosine b equals minus 29 48. That tells me something. I'm going to find out here in a second what its angle is. But it tells me that I have a negative cosine. And because I have a negative cosine value there, it tells me that I have an obtuse angle, an angle greater than 90 degrees, because that angle is going to fall into the second quadrant, and that's where negative cosines exist. So let's find what b is on inverse sine negative 29 divided by 48. I don't need a negative in there, folks. Oh, cosine, sorry. Inverse cosine, that's what I did. Inverse cosine minus 29 divided by 48. Inverse cosine 29 divided by 48. Okay. I kept fat figuring, put negatives in there, and that's what I'm looking at. Cosine of the inverse cosine of the value, since I already know its value is the negative puts me in the second quadrant, so it's an obtuse angle. I just need to find the cosine of 29 48ths, and that becomes b equals 52.8. Well, we can round up to 53 degrees for the purposes of what we're doing right now. So, angle B, that's not right. Angle B is 53 degrees itself. I know it's in the other quadrant, so it's 180 degrees. minus 53. And so that produces an angle of 127 degrees. Like I say, wait a minute, 53 degrees, that wasn't making sense. And the reason why is because I had to find its other angle in the second quadrant, which gives me an angle degree of 127 degrees. From there, I can use my sines and cosines, my law of sines to figure out any other information I need. So I don't know angle A. So let's go ahead and do A over to sine of A. I know the B's, so we can do 9 all over sine of 127. Solve that for A. Back up. I don't know sine of A. This just got a little messy. That's my unknown. My A, I know this one now. That's 6. That's where we go. All right, let's solve that for sine of A. Six times sine 127 divided by 9. Sine of A equals 0.5324. I know it's an acute angle, so I'm only looking at that version of it. And so let's take the inverse sine of 0.5324. Produces an angle of roughly 32. So angle A up here, 32 degrees. And to find the third side, it's 180 degrees total. So 127 plus 32 gives me 159. Subtract that from 180 gives me 21. Sorry folks, I need to add this up here. 159, 180 minus 159 gives me 21 degrees. So there I was able to go ahead and solve a triangle that had 3 sides that were known. What I started off with first is I used a law of cosines to find out what one angle was. And the angle I chose was the angle opposite the largest side. From there, I went ahead and used a law of sines. And I used that, and I did that because I know the last 2 angles were going to be acute angles, which helps reduce where I'm looking at. And you'll discover that as you work on your problems. So then I used a law of sines to find one additional angle, and then from that I knew that the interior angles of a triangle added up to 180 degrees.